Hi, welcome back to McClutchy Maths. My name is Natalie McClutchy and we are on our 5th video in our quadratic series. Today we're actually stepping up from expressions to solving quadratic equations. Okay, so actually trying to find out the values of x. And we're going to use something called the null factor law. I'm assuming before you start this video that you know all of the prerequisite knowledge that you need to know. You've watched the advanced algebra playlist, you've also watched a bit of surds, and you can also work with solving normal equations, and you also know all about quadratics, non-monic and monic. Okay, so let's talk about first how you can engage further with us here at McClutchy Maths, and then we'll get going on some examples. So firstly, like and subscribe and hit that notifications bell so you'll know when video 6 is available to watch. You can say thanks for the work we've put in here at the channel by donating $2 using your secure PayPal account by hitting the little love heart button. That's called Super Thanks. Otherwise, why not consider telling someone about the video? You could share it with the link, or even put on your class 1 note, or even tell us in the comments. Okay, let's talk about what the word null factor law means. So the word null, you probably don't use this word a whole lot anymore, but it is a synonym for the word zero. So it's like a zero factor law. And it revolves around the concept that when we multiply anything by zero, the answer is always going to be zero. So for example, 3 times 0 equals 0. 1,000,000 times 0 equals 0. And when we have letters, y times 0 is also equal to 0. Now when we have two unknown variables like j multiplied by k, written as jk, and if I multiply those two together and I get an answer of 0, I can assume that either j is 0 or k is 0, or even both are 0 in order to make this equation true. This is the whole foundation for what we're going to be doing today. So when we factorize expressions to solve an equation, we can consider solutions using that null factor law. For example, in this case here, I've got two things multiplied together. That's what brackets means. M multiplied by m minus 2, the answer is 0. So what I can assume here is that either m equals 0 or m minus 2 equals 0. So there's my first factor here, and I've got my second factor here. Both of those could be 0, or one of them could be 0 to make the equation true. So there I'm going to have two possible solutions. If m is equal to 0, I get m equals 0, or if m minus 2 equals 0, then m equals 2, okay, by solving the equation. Okay, so to solve a quadratic equation, firstly we're going to transpose the equation into this form, ax squared plus bx plus c equals 0. That means rearrange whatever form it's given in, put it so that you've got something equal to 0, which will enable you to use the null factor law. Then if you've got a common factor of a, b and c, divide everything by that common factor. Divide a, divide b, divide c, and of course we know 0 divided by that factor will also give us 0 as well. It's going to simplify the whole thing out. It could turn a non-monic quadratic into a monic quadratic. Then we factorize this part here, and then we're going to apply the null factor law to both parts of the factorized equation. So we're going to have two sets of brackets. This set of brackets will be equal to 0. That set of brackets will be equal to 0. We'll have two solutions. Okay, so first of all, we've got our first worked example. X squared take away 3x equals 0. So we're going to transpose that into that form. It's already there for us. We've got 0 all on its own. That's what we're trying to make sure we have, is a 0 all by itself. Our second step is to look for a common factor for a, b and c. So I have a coefficient of 1 here, a coefficient of negative 3. There's no common factor for the coefficients, so this whole step does not apply. Okay, so now I'm going to factorize. My common factor here is x, outside of brackets, x minus 3, still equal to 0. So that means I've got two solutions, either x equals 0 or x minus 3 equals 0. And if x minus 3 equals 0, I add 3 to both sides, I get x equals 3. Now, we haven't got a series on this, but I'll just tell you why you've got two possible answers for x. When this is graphed, it's going to graph in a curve, and it's going to look like a smiley face or a frowny face. And that's going to pass through the axes in two places, generally speaking. Okay, so sometimes it might pass in no places, and sometimes it might pass in one place. But for these types of quadratics, it's passing in two. It's passing through the x-axis. So that's why we have two solutions. Here's our next example here. J squared minus 16 equals 0. Once again, our first step is always that transposing. It's already done for us, so don't worry there. No common factor with those coefficients, so we don't have to do that step there either. Now it's time to factorize, and I can see a squared number take away another squared number. So we're going to use difference of two squares here. And I'm going to put that into brackets j plus 4, brackets j minus 4 equals 0. Applying that null factor law now, I'm going to have j plus 4 equals 0 and j minus 4 equals 0, which means j could be positive or negative 4. And I can simply write that nice and simply plus over a minus there. I've got two solutions. Let's look at worked example 3. X squared minus 2 equals 15. Now you'll notice it's not equal to 0, so this is where that transposing has to take place. I have to subtract 15 from both sides, and I get a 0 on this side, and negative 2 take away 15 more gives me negative 17. Okay, so now I've got x squared take away 17 equals 0. Now, is there a common factor? No, so that will not apply. So I'm moving on to the factorising step. Now, this is difference of two squares. We talked about this in our last video. We can consider negative 17 or just 17 on its own to be a surd. Okay, it's root 17 squared, and these two cancel out to make just 17. So I can now factorise this. I've got x plus root 17 multiplied by x minus root 17, and that's equal to 0, which means that this expression here could be equal to 0, and this expression here could also be equal to 0 using that null factor law, which means x is equal to plus or minus root 17. There we go. So you could also show the step in here to solve those equations, but most of us can do that by inspection. Let's look at example 4. So once again, when I look at this one, there's no transposing to be done. There's no common factors. So I can skip steps 1 and 2, and I can go straight into factorising. Now, I could treat this like a monic quadratic, look for factor pairs of this one that add to this one, which would be 3 plus 3, or 3 times 3 makes 6, but recognise that that is a perfect square. So k plus 3 all squared equals 0. Now there's a quick way to solve this. I could take the square root of both sides to undo squared, and that gives me k plus 3 equals 0. Then when I apply the null factor law, I end up with one solution, and that's k equals negative 3. And the reason why it doesn't have two solutions is that if I graphed this, then the positive curve would actually only touch the x-axis in one position. So therefore, I've only got one solution. Let's look at example 5. 2f squared take away 10f plus 12 equals 0. Now in this particular situation, I've got to transpose the equation. No, it's already equal to 0, but there is a common factor, and the common factor is 2. So if I divide everything by 2, divide 2f squared by 2, divide negative 10f by 2, divided by 12 divided by 2, and 0 divided by 2, I'm going to end up with f squared take away 5f plus 6 equals 0. Now it's time to factorise. It's not a perfect square, but what I can do is look for those factor pairs of positive 6 that make negative 5. And I need to be thinking about negative factor pairs because a negative times a negative makes a positive. So I'm going to be looking at those that add together to make b, and I've got this pair here, negative 3 times negative 2 makes positive 6. Negative 3, take away 2 more, gives me negative 5. Now I'm going to apply the, got that factorised out there, which is wonderful. And now I'm going to apply that null factor law to both parts of the equation. So I'll have k minus 3 equals 0, or k minus 2 equals 0. And when I solve those equations, I end up with positive 3 or positive 2. So once again, two solutions. Okay, we're on to our 6th worked example now. So 10c squared minus 13c minus 3 equals 0. So once again, don't need to transpose, and there are no common factors between 10, negative 13 and negative 3, so I can skip those two steps and go straight on to factorising. And because this is a non-monic, then I need to think about multiplying the 10 with the minus 3. So that's a and c, that gives me negative 30. So now I'm looking for factor pairs of negative 30 that add together to make negative 13. Okay, so let's think of those. Well, I've got negative 15 and positive 2. So negative 15 plus 2 gives me negative 13. So this means I'm going to be breaking negative 13c now into a negative 15c and a positive 2c to factorise those into two groups. So here we go, that's what that looks like here. So now my common factor between 10c squared and 15c is going to be 5c at the front of brackets. Okay, and I don't have a common factor here, so I'll just put a 1 there. Okay, and you'll notice that I've now got two factors that are the same, 2c minus 3. So let's put that at the front, and the 5c plus 1 will go in the second set of brackets. I've now got this all set to 0. My next step is to apply that null factor law and solve these two equations. Now the rest of them we could just do by inspection, but these we have to show some working. So let's set 2c minus 3 equals 0 and 5c plus 1 equals 0. And we can solve this one over here. We're going to add 3 to both sides, then divide both sides by 2. We get a fraction, 3 over 2. Let's solve this one over here as well. So let's take 1 away from both sides. We get 5c equals negative 1, divide both sides by 5, and we get c equals negative 1/5. So we've got two fraction solutions here. A bit tricky, a bit more difficult. So just remember to not use your calculators to put those in decimal form. Keep them in fraction form. Okay, we're moving on a bit further here. I've now got what's called a hidden quadratic. Okay, so this doesn't look like a quadratic. There's no squares, but we do need to transpose to get it into that ax squared plus bx plus c equals 0 form. So that's our first step. So to do that, I need to get rid of this denominator here. I'm going to multiply both sides by y. If I multiply this by y, I'll end up with y divided by y, which will cancel these out. Multiply this side by y, I get y squared. So now I've got that disguised quadratic has now become an actual quadratic. We've still got to transpose and get everything all on the same side as the equal sign and a 0 on the other side. So let's take the y and the 6 away from both sides. We'll end up with y squared take away y, take away 6 equals 0. Now I've got something to work with. So what I want to do is factorize that out. We could finish that with all those remaining steps. I'm not going to show you how to do that because we've been doing that all video. So why don't you see if you can have a go yourself. But let's move on to the next example here. Once again, this has not been transposed, so let's do that in our first step and add 3 to both sides, and we'll get this one here. We've got a common factor of 3. Let's divide everything by 3, and we're going to end up with x squared plus 4x plus 1 equals 0. Okay, now in this particular situation, you might be thinking, well, I can't factorize that. It's not a square, a perfect square. It's not difference of two squares. It's not even a monic quadratic that can be factorized because factor pairs of 1 are only 1. But we could complete the square. Okay, so we've got that issue there. Let's complete the square. That's what we did in our last video. So if we now take half of 4 and square it, we're going to add 4 and take 4 away. Okay, so now let's factorize this part here, and we're going to end up with x plus 2 all squared, and negative 4 plus 1 makes negative 3. Okay, so we've got a little bit of extra complexity here. I'm kind of bringing every concept together. But now we've got difference of two squares. So we've got x plus 2 all squared. Take away this 3. Now you might be thinking that's not a squared number. We've talked about this. It is a surd of root 3. And so when I now make difference of two squareds, I've got plus root 3 minus root 3. Now the last step here is to use my null factor law for this part here. So either this is equal to 0 or that is equal to 0. So two solutions looks like that. Okay, and I really just need to move the 2 and the root 3 to the other side to get x all by itself to solve. So I'm going to have it either equals negative 2, take away root 3, or it's going to be negative 2 plus root 3. I could also write that as negative 2 plus or minus root 3. And that's my two solutions there. Well, that's all we have time for in the video. We went from simple to very complex and we combined lots and lots of ideas together. I really recommend that you have another go at watching some of those examples again. Pause and reflect. See if you can work it out on paper as we go. If you've got any questions or would like some extra resources, contact me at mcclutchymaths@yahoo.com. You've been watching McClutchy Maths. I'm Natalie McClutchy. Have an amazing day.